Good morning, ladies and gentlemen. This is Ben Keyser with Applied Flow Technology. I hope that you are all doing very well and having a wonderful week. And welcome to the first AFT webinar of 2020, a brand new decade of webinars, a brand new decade of outstanding and educational content to help you learn how to model your piping systems more effectively and efficiently. And thank you again all for joining me today. I'm really excited about this webinar. We're going to talk about some really useful features such as model importing from neutral files, importing and exporting with Excel, and also I want to give you all a newsworthy item that we are just about to release the next version of AFT Fathom, which will be AFT Fathom 11. The release is set to drop at any moment. We are putting on the finishing touches and the final polishes right now, and we're very excited about the new features that will be coming out with the next version. And I'm actually going to show you one of them in regards to pump and system curves, and I'm really excited about it. It works very well, and so if you want to ensure that you are notified for when we release Fathom 11, as well as when we put out AFT Arrow 8 and AFT Impulse 8 in the coming months, be sure to subscribe to receive notifications from our website. Here's where you can do that. If you go to aft.com, under support, click on manage notifications, and this is where everybody should fill out this form right here and at least choose to subscribe to the maintenance notifications for Fathom and Arrow and Impulse. And if you do that, we will send you an email whenever we put out a new maintenance release or a new version, letting you know that it's available. And in that email, we will also provide the download link. That way you can download the software and get it installed. And so even if you don't have installation privileges, you should still fill out this form and subscribe, because then you can go to your IT department and have them get it installed for you. And so be sure to sign up for that. We also make big announcements like new products and new versions in our AFT newsletter. So be sure to sign up for that as well. All right, let's go ahead and just get right down to it. The first thing I'm going to demonstrate today is how you can import a neutral file, such as a piping component file, to allow AFT Fathom to build the model of your piping system for you. And so this was one of the key new features that came out with our previous version, Fathom 10, Arrow 7, and Impulse 7. And here's how you do it, is if you go to the File menu, as you can see, I've got a blank workspace. The thing I'm going to go down to is Import Piping Layout From. As you can see, there are 4 separate neutral file types that we can import from. There is a piping component file. That will typically come from isometric drawings. So whenever you're working with a certain CAD program and it's making the isometric drawings for you and it saves your isometrics, it will typically automatically create this piping component file for you with isogen standards. And so that's just a text file that contains all of your piping information. And so that's what I'm going to demonstrate how to import today. We can also import Caesar 2 neutral files, GIS Shape Files, and EPANet files. So here's what this looks like. If I go to click on Piping Component File, what it does is it changes the quick access panel to give me a lot of flexibility in how I go about importing a PCF file or any other neutral file to build my piping system. And so here's what I would do next for the next step is I'm going to click on the 3 dots in the upper right hand corner right here on that button. And what you're needing to do is to search for a folder on your computer that has the neutral files. So I have a folder right here called Model Importing, and voila. So right now, because I chose the PCF file option, this is finding the various PCF files in that folder that I could import. And so here's an example of what it looks like. If I click on one of them, PCF file number 1, the first thing it does is it pulls up a paste preview mode that will give you an idea of what your system is going to look like when you go to import it in. And so I can zoom in and out. I can click my mouse wheel and drag, and I can pan around the workspace. I can click this button in the upper left corner to move the system around. So that's one of the benefits of being able to see what your system is going to look like. The next area of the PCF importing wizard is this portion right here. This is what gives you a lot of flexibility as to which components are going to get imported and how you're going to import them. And so what it's doing is it's reading the object from the piping component file, and then it's translating it into a AFT object. So as you can see, an elbow is going to be translated into a bend junction, while a reducer will become an area change and a valve will become a valve, so on and so forth. Now here's where this gets interesting, is let's say that this particular valve right here, when I click on it, let's see here, what did I do? I must have, let's try this again. Technical difficulty here. All right, so go back into the PCF file and search the folder where I have it. There we go. All right. So let's click on one of these valves. This one, there we go. That's what I was wanting it to do. So I selected this particular valve, which is this valve right here on the workspace. Let's say that in reality, that valve is actually supposed to be a control valve. Well, what I can do is I can click on the drop-down menu in the AFT object column, and I can change it from a regular valve into a control valve type. And as you can see, it changed the valve type right here on the workspace. So this is what gives you a lot of flexibility over things that you want to import in different ways. So be sure to click on the drop-down menus to see what's available. The next thing is the property window. If you select an object like I have here and click on property window, this is going to bring up a list of the information that was pertinent from the piping component file that is required for the AFT model. Now, there's a lot more information that's in the PCF files that we just don't need. So if you click on Show Advanced Properties, here's all the advanced information that is included in the PCF file for that particular object, but it's not needed for the flow model. However, if you still want to keep all this information in the flow model itself, what you can do is you can go in and you can, I'm going to click on Close, and what I'm going to do is I'm going to check this box down at the bottom right here to import that data to the notes fields. So if I import that data, in every pipe and junction property window, there's a notes tab, and it'll import all those notes into each of those respective tabs for each object. All right. So now what I'm going to do is I'm going to zoom out, and I'm going to drag my model over a little bit to the right, and I'm going to zoom to fit here, and I'm going to import the model. Nice and quick. So now I have a new system on my workspace. Let's say that one person worked on that PCF file, and then a different person worked on another one. So this is another PCF file, which could be of the same system, but somebody else worked on it. And so what you need to do is you need to basically merge the two systems together. Well, you can easily do that, and you can import as many PCF files as you want. Now, something that I want to point out is in the PCF files, there's two words that can be used potentially for elbow fittings. Sometimes PCF files will use the word bend, and sometimes they'll actually use the word elbow. So in the case of this particular system here, the PCF file used the word bend, and I have this box right here, which is going to import the bends as pipes. So instead of using actual elbow junctions just like this is one way that it's cleaning up the model, because it's not going to put elbow junctions in these areas. What this is doing is it's turning on the pipe segment tool to essentially put right angles at these different points in the model. Now you have the option to be able to turn that on and off. And so if I uncheck that box to import bends as pipes, and I want to show the elbows explicitly in the model, simply uncheck that box, and that way it'll put the elbow junctions there for you. That may be a decent way to start off, just to explicitly show where everything is. But if you have a really large system with lots of fittings and lots of turns, maybe you do want to import your bends as pipes, and that way it'll help reduce the amount of clutter in your system. All right, so now I'm going to go ahead and import this system next, and it's going to build it for me. And I'm going to collapse my quick access panel, and we can see that we now have two systems built and defined on the workspace, and it does include some basic information that is inputted into your model. So if I was to open up any pipe or junction, it's bringing in the inner diameter, the length of the model, and here's where you can see all the notes that I brought in for each object. And so consequently with that, if you click on the Notes tab in the Model Data window, here's where you can see all of the notes in the entire model itself. There's a lot of them. You can print it out if you want. So I have length information for every pipe. I have a inner diameter for every pipe, and it also will bring in elevation information for the junctions. So currently, those are the pieces of input that are going to be getting defined in your model when you import your system. Now let me start fresh one more time, because there's one more PCF file that I want to import, and I want to show you a little nuance of something that you might need to play around with a little bit when you go to do your model importing. So let me go ahead and go back into my PCF import wizard. I'll go back to the folder that has the PCF files. All right. So this is a system that is really, really large. And as you can see, if you zoom in, there's a whole bunch of junctions and pipes that are all cluttered up and laying on top of each other. And so this is one of the things where there's a little bit of difficulty because of the way that CAD software works versus the way that our software works. And so you're going to have to do a little bit of cleanup on this. It's because the AFT software is a two-dimensional interface, and it's not going to be able to show pipes on top of pipes if they are in the same area as each other if you're looking down a pipe rack. So what I would recommend is to play around with the scaling to scale up the model to where it spreads everything out a lot more nicely. So what I'm going to do is I'm going to turn off auto scaling, and because I've already done this, I know that the magical number is probably about 350% for this particular system. So as you can see, when I spread things out by 350%, it eliminates a lot of that clutter very nicely. If I zoom out and scroll over to that area where things are on top of each other, which is in this particular section of the system, everything has been spread out a lot more nicely. So now when I go in and zoom in, you can see that all of your junctions and pipes are connected with each other appropriately. You might need to spread it out a little bit more. 350 is a good number that works in this particular case. I could bump it up to 400 if I want, and it might do just a slightly better job of spreading things out. And so when you have a large system and you see objects cluttered up like that, the first thing that you'll want to do is to start playing around with the scaling and scale it up more and more, and that's what's going to spread those objects out. That way, when you go to do the import, it does a much nicer job. And so, as you can see, it builds the model very, very quickly, and it's a major, major time saver. It might require a little bit of cleanup, but imagine how long it would take to build this model if you were trying to build it from scratch by hand. It would take a lot longer of a time to do that. So that's importing a piping component file. The other neutral file format options work in basically the exact same way, but just for different neutral file formats. So let me show you what a Caesar 2 neutral file looks like really quick here. So I'm going to go to File, Import Piping Layout, Caesar 2, and I do the same thing. I go back to where my folder is that has the Caesar 2 neutral files, and here it is. So as you can see, I'm including the elbows as junctions. If I want to bring them in as pipes, I can uncheck that box, and that way I have one single pipe in this model. So this whole, if I select that, that whole pipe is one single pipe, and it's using the segment tool to be able to have all these directional changes. Now, that does not mean that the model knows that you actually have an elbow at all of these different locations. Fathom doesn't know that. This is only a graphical layout, and it's not to scale. And so if you want to actually represent the losses for elbows on that pipe, you would have to either use actual elbow junctions, or if you open up the pipe window itself, let me select it again here. So I've got 3,183 inches. What I would want to do is count up the number of elbows that I have in that run of pipe, and I can go to fittings and losses, specify fittings and losses, and then just specify however many there are. Maybe there's 10 of them. And so that's going to give me my total K factor for that particular fitting, and that adds on an additional pressure loss to your pipe in order to account for your losses through fittings. So that's what a Caesar 2 neutral file import looks like. The other two basically function in the exact same way. GIS and EPANet. Here's an example of a GIS file import where you would simply browse again to where you have your model saved. Select the shape files, and this is my large network of piping, and this comes straight from a GIS shape file. And it doesn't take too long for it to import. And it's almost done. And voila. And so now if I zoom way in, we can see where things are. Now again, this is where you're going to have to do some cleanup. In the software, you cannot have a pipe just ending at the end of a pipe here. You have to connect it to a junction. And so here's the conundrum. Is the end of this pipe just dumping out into the atmosphere, or is it actually supposed to be connected to this particular pipe right there? Well, we don't know. So this is where your GIS team is going to have to do a bit better of a job to make sure that things are cleaned up for a flow model. In this particular system here, this is maybe a well pad where it's just dumping into that well pad right here, and it may not be connected to that pipe. And so the way that the GIS file may have been drawn is that the pipe literally ends right here as it dumps into the well pad. But the thing is, we can't model it that way. You have to put a junction at the outlet of that pipe. Perhaps it's just a reservoir, but ultimately something has to be connected to it. And if I need to actually connect it to this particular pipe here, then what you could do is put a branch junction in and split the pipe. Let's see. This is a really, really short pipe. 0.05. There we go. So now this branch is connected to these two pipes. And it looks like this isn't even, there we go. So as you can see here, you're just going to have to play around with it. It's going to require a little bit of cleaning up. So if this pipe is actually supposed to be connected there and there is no reservoir, that's how you'll have to, that's how you'll have to connect things up. But overall, still a major time saver where you don't have to build this whole entire system from scratch. All right, that's model importing. Let's talk about the Excel integration now. So I'm going to go ahead and close Fathom, and I'm going to open up a new fresh instance of the software. In AFT software, for a long time, there has been the capability to import changes to a model from an Excel spreadsheet. It was a very powerful feature, and it's been dramatically enhanced and improved, and I'm going to show you what those enhancements are today. So let me go ahead and open up my model first. All right. There we go. Perfect. And let me open up that folder. All right. Just getting some files open here that we're going to need. Okay. So here I have a piping system, which is a modified version of our hot water system example. FYI, if you're not familiar, we have tons of walkthrough tutorials built into the software that will help you learn how to use the software more effectively and efficiently. So if you go to the help menu and then show examples and pick your favorite units, this is where you can find several walkthrough tutorials in our example help file. And so the hot water system looks like this, and I'm modeling right now a modified version of this. So in this particular system, I have a hot water network that just circulates hot water throughout the system, and I have several families of scenarios. So here I have three families. The first family right here, this is going to keep my flow control valves failed open. And what I'm going to be doing is I'm going to be changing the flow right through the system by changing the pump speeds. So in each scenario, I'm going to change the speed. So this is going to be my 95% speed scenario, 90% speed, and 85% speed. So what I did was in the base scenario of the model, I built the system of all the pipes and junctions, but I didn't define very much information. After that, I created this scenario right here, which is a new parent for 3 children, where I'm going to change the pump speed. The next thing that I did was I wanted to select this particular scenario here. I right-clicked and I said clone with children. And when you do that, it then creates this family of scenarios. So in this family of the scenarios, I'm still not fixing the flow through the system with the control valves. I'm changing the flow by putting a flow set point on each of the pumps. So what Fathom is going to do is it's going to change the pump speed in order to meet my flow set point through the affinity laws. And then last but not least, I cloned the family of scenarios here one more time to create this family of scenarios, where in that last family, I am modeling every single pump at 100% speed, and then I'm using the control valves to fix the flow rate through them. So what I needed to do was to go into each parent and set things up. So in this first parent scenario here, what I've done is for each of the pumps, I've left them at 100% speed. And what I'm going to do is I'm going to use an Excel spreadsheet to automatically change these 3 child scenarios to the different speeds. So in the 95% speed scenario, each pump is going to operate at 95% speed, so on and so forth. Now, for these 2 control valves, I had to go in and fail those open. So if you open up one of these control valves, you can see on the optional tab that it is fully open, no control. It's basically pretending that the control valve is not even there. So I'm changing flow through the system simply by changing the pump speeds on my pumps. If I was to load any of those other scenarios, you would see that the same special condition is applied to being failed open. So that's what I did for that particular parent scenario. The next parent scenario here is where I kept both of the control valves failed open to where they're not controlling, but instead of using a fixed speed, it's doing a controlled pump set point. Now, what I did was I selected these 3 pumps on the workspace, and I did a global junction edit where I changed each of these 3 pumps to use the controlled pump set point in the parent scenario. The reason why is because if I want to import changes from an Excel spreadsheet for flow set points, the placeholder has to be changed to a flow set point on each of the pumps for them to be able to see that data. So if I left them as speed controlled, it's not going to take the changes. Last but not least, in the final family of scenarios, each of the 3 pumps are operating at 100% speed, and I'm going to keep my control valves in play this time, and I'm going to change the flow rate through the control valves from my spreadsheet. Now, you can also see that I have not specified any input information for the piping details. So all the piping information is gone. What I'm going to need to do is in the base scenario is I'm going to need to define some sort of placeholder input. So what I'm going to do is I'm going to do a global edit, global pipe edit, and I'm going to set all the pipes to be steel, and they're all going to be 4 inches in diameter, 1 foot long. Click OK. I'm only making these changes right here. And the reason why is because if I want to import changes for various parameters like pipe diameter or pipe length, it's not going to be able to import to blank fields. You have to put placeholders there. And also is what sets up the units for you. So that way when you import from Excel, Excel just sees a number, but in Fathom, that's where you're going to have your units all set up. So as you can see, I have a placeholder value for the length in all my pipes. They're all set to use feet, and I set them all to be steel, 4-inch diameter, standard schedule 40. And in my Excel spreadsheet, I'm going to import in the actual length and actual nominal size and schedule for every single pipe in the model. And when you make that change to the base scenario level, it will pass those changes down to all the rest of the scenarios in the model as well, as long as they've not already changed their own input for diameter and length. So as I mentioned, The ability to import changes from Excel is a feature that we've had for a long time. If you were using Fathom 9 and previous, then what you would have to do is go to the Help menu, and you'd have to open up the Help file here and do a keyword search for import Excel change data. And previously, you would have to create a spreadsheet on your own. So in the past, the Excel import change data here, let's see. I'm looking for the appropriate topic, and I'm not seeing it in here. Anyway, what you'd have to do is you'd have to create the spreadsheet on your own. The help file would have a whole bunch of codes for parameters. So the pipe length parameter might be code 1600, and the diameter code for a pipe might be 1601. Essentially, you would have to create your own spreadsheet, and you'd always have to refer to the help file to get the right codes to import things properly. What we have done is we have created a template for you. So if you were to browse to where Fathom is installed on your computer, which here it is on my machine, we've provided a Excel import workbook template for you. Now, don't do what I'm about to do. Do not open this spreadsheet from this folder, because you don't want to take a chance of accidentally messing up the template that we gave to you. So instead, copy that file and paste it somewhere else. So I'm going to copy this and I'm going to paste it onto my onto my desktop, and I'm going to open it from here. So here's the template that we've provided. Once it opens up, I'll move it over. There we go. So here's what this looks like. First of all, we made the change to include drop-down menus rather than having to put in your own codes or parameters. So let's say I want to change a control valve setting. The first thing is in the apply column, I would either choose yes or no, depending on if I want to apply certain changes. You can say no, and that way it wouldn't apply those changes if you want. The object type is either going to be a pipe or a junction. So let's choose control valve. So if I choose control valve, the next thing that I need to do is I need to specify an object number. That is simply the pipe or junction ID number on the workspace. So maybe it's J34 as an example. Next, I go to the parameter column, and this is where I would need to choose which parameter in the model I want to change. And these are all the options. So let's do the control setting. So in the control setting, that's how I'm going to change the set point. And this is where you would define a change code. You could set the value to a certain number, or you can change a parameter by an amount or by a percentage. So let's say you want to decrease the open percentage for all your control valves by 5%, then that's how you can change the set point by a percentage rather than an actual number. And then the last thing is to specify the value itself. So because I said set equal to value, this is going to set the value of the control valve set point to a number of 50, and then the units are going to be whatever the units are that are defined in the model. So enhancement number one is we created the spreadsheet for you. Enhancement number two is we prepared the drop-down menus. That way you don't have to constantly refer to the help menus to get the right parameter codes. The last enhancement is the scenario path. So in the previous method where you would do a import from a spreadsheet, is you would have to make changes to each individual scenario one at a time. So my particular model, what I would have to do is I would have to create a separate spreadsheet for each individual scenario, or constantly change my spreadsheet whenever I wanted to go and import changes to another scenario. Now, we've made this a lot more powerful, where you can import changes to any scenario that you want in the model. So with that, I'm going to go ahead and close the template and show you the spreadsheet for this particular system. So here's my spreadsheet. So what I'm importing here is pipe length. Here's all the pipe numbers on the workspace, and here's all the values. Because all my units are already set up in the model as feet, these are going to end up being length units of feet as well. So I've got pipe length, I have nominal size, 6-inch, and some pipes are 4-inch. And then next I have pipe schedule. So they're all going to be changed to standard schedule 40. Now, as you can see here, I'm importing these changes to the base scenario. Again, if I import those changes to the base scenario and I've not changed piping information in any of the other scenarios, it's going to pass those changes down to all of the child scenarios as well. And so that's where I'm doing my changes for the piping information. Next, if I scroll down, here's where I have my different junction values. So in the first section here, I'm changing the pumps based upon speed. So I have 100% speed, and then I have 95% speed, 90%, 85%. And you can see how I'm changing all 3 pumps on the workspace for each particular change. And then I told Excel which specific scenario I want those changes to go into. So it's going to import each of those changes to the proper scenarios as I have defined here. The next family is to do flow set points. So these 3 pumps are going to be 500 gallons per minute in this scenario, 400 gallons per minute in this scenario, 300 gallons per minute in that scenario. And then last but not least, in my final family of scenarios, all pumps operate at 100% speed. So in that case, I'm changing the control setting of my control valves. And these are the flow set points that I'm going to be using for each of the respective scenarios. Now, the question is, how do you get the full scenario path name into the spreadsheet? That seems like a real pain if you would have to go in and look at your model and type out the full scenario path, which is actually given down here in the bottom left corner of your window. So that would be a real pain if I'm having to go in and manually type in the full scenario path that's displayed on the bottom and make sure that I get every digit exactly correct. Well, no. We made it a lot easier for you. So one way is you can simply right click on any scenario and say copy scenario path name, and then you can simply paste it right into your spreadsheet. But in my particular scenario, or in my particular model, I have tons of scenarios here. You might have hundreds of scenarios in your model. I don't want to have to go through and manually copy and paste every single scenario by scenario. So instead, just right click on any scenario and you can use this option to save the scenario names to a file. This will save the scenario names to a text file, and I've already done that, and here's what it looks like. So I basically exported the full scenario path of all the scenarios into this text file. If you wanted to, you have a couple of options. A, you could leave the scenario names in your text file and then just copy and paste them in directly into your spreadsheet in that fashion. Or if you want to, you could create your own separate tab where you can essentially, clicked on the wrong button there, where you could basically go in and copy the full scenario paths from your text file, and there we go. And that way, if you wanted to, you can actually reference the cells in the other tab if you like. So multiple ways to skin the cat. Ultimately, it's a lot easier for you to be able to just copy and paste from a text file to get those full scenario paths. That way, everything is correct. So now in my model, everything is all set up and all ready to import into the model. So in order to do that, what you would do is go to File, and then you would say Import Excel Change Data. Pick your spreadsheet that you're importing from, and that's going to start reading in the changes for each row. It's telling you what it's doing in the bottom right or left corner, and then it's going to go through and start applying those changes to each individual scenario. So here I had 99 rows of data in my spreadsheet, and it made 99 changes to my model. So it didn't mess up. It didn't give me any errors. So that's good. But let's spot check some things to make sure it did what it's supposed to. If I go to the model data, bam, here's all my piping information. I've got the correct length specified, the proper sizes. Some are 6-inch, some are 4-inch, proper schedules. And then if I go into each of these scenarios, this pump should be 90% speed, and it is. This pump should also be 90% speed, and it is. If I go to the bottom scenario, they should all be 85% speed. And as you can see, they are. If I go to the next family of scenarios, here, this should be all 300 gallons per minute, and it is. If I double click on the 500 gallon per minute scenario, this should be 500 GPM, and it is. And then lastly, if I go to the last family of scenarios and I right click on the control valves, I should see 1,000 gallons per minute here and 1,000 here. I should then see 1250 in this scenario and 1250 in that scenario, and boom, there it is. So that is what it looks like to import changes from an Excel spreadsheet. Again, where do we provide that template for you? It's where the software is installed in your computer. So browse to wherever the AFT application folder is on your machine, and there's your workbook template that you can start from. Again, copy that file, paste it somewhere else on your computer, and open it from somewhere else. That way you don't mess up the template that we've given you. Same thing goes for AFT Arrow. Here's your Arrow Excel import workbook, and here's your Impulse Excel import workbook. And that's all there is to it for importing changes from Excel. So that's pretty exciting. Let's talk about going the other direction now. What does it look like to export changes, or what does it look like to export results from AFT software into an Excel spreadsheet? So let me go ahead and restart Fathom here. All right. And let me open up my model. Okay. Now, this particular example is actually based on a blog article that one of our previous applications engineers, who is now a software developer, wrote a while back. So if you go to Learning Center and then Tips and Tricks, and then you can use the magnifying glass to do a keyword search. Just do a keyword search for Excel, and you'll find various blog articles that talk about how to use Excel in different ways with our software. And it's this very first one here, paint a clear picture faster than ever with AFT's new Excel export manager. So if you go through and read this particular article, you'll be able to see how the Excel export manager can be set up to model the system that I'm demonstrating for you. But because I like to make things special and I like to push the envelope a little bit, I took things a little bit further than what this article lays out. This just does for one scenario. I've got it for multiple scenarios, and I'll show you what I'm doing. So in this particular system, one of the things I care about is a certain temperature at all of these outlet points. And this system is modeling heat transfer. And so I have to have a certain temperature that I care about at each of those outlet points. And I have a pump in my system, and there are 3 scenarios that I'm modeling. In the base scenario, the pump is modeled at 100% speed, and then I have 2 other scenarios where it's operating at 95% speed and 90% speed. So let me go ahead and run the base scenario, and we'll take a look at some results together to see what's going on. So we run the model, it converges pretty quickly. We take a look at the output, and what I have done is I have already pre-configured the whole output window using the output control button here. So what I've already done is I've already gone into the output control and I have filtered out various parameters for things. So as you can see, for the piping section, I'm only displaying 4 parameters for a handful of pipes. So I'm only showing the name of the pipe, flow rate, velocity, and pressure loss in these units. And then the way that I chose which pipes I want to show them in is if you click on Show Pipes and Junctions, the only place that I'm showing these results in the output window is on the outlets. Now, one thing that I noted is that temperature is important to me, but I am not currently displaying temperature in the output window. There's a reason for that, and you're going to see why when I demonstrate the Excel Export Manager. So that's what we have for piping. If we were to look at the pump summary, the pump summary window has also been changed. So let me make that a little bit larger. So for the pump summary, I'm only showing flow rate, head rise, percent of BEP, and the overall horsepower. It's at 342% of the best efficiency point. That doesn't matter. The idea is to demonstrate here the Excel Export Manager. So don't worry about that being way out of whack. All right, clearly the pump was probably not sized properly. All right, so I've only got a few parameters for the pumps. And then for the valves, this valve summary is actually the default valve summary that is given. So if I clicked on Fathom Default, you're seeing the same exact parameters. So that's how I've set things up in the output table. If we go to the graph results, I have a couple of graphs that I've already prepared. I've prepared a profile plot and a pump and system curve. So if I was to double click on either of these graphs, it's going to regenerate the graph list items on the spot. So for one of them, this is called my 3-parameter header graph. I'm showing pressure, velocity, and temperature for the common header, essentially, which is this flow path here. So that is my flow path for the 3-parameter header, pressure, velocity, and temperature. And then here's my pump and system curve. Now, I know what you're probably thinking here is, hey, I have 3 different scenarios where I've got 100% speed, 95% speed, and 90% speed. I would really like to be able to have all 3 pump curves plotted together on the same graph. That way you can see how things are changing operational wise with your system. And the answer is yes, you can do this with the Excel Export Manager, and I'm going to show you in just a second. So those are some pieces of data that I wanted to point out. Now, what is the Excel Export Manager button? It's this guy right here on the main toolbar. So if I go in and I open up the Excel Export Manager, it takes just a second to open, but there it is. I have listed a whole bunch of parameters to have their data sent to an Excel spreadsheet. So in order to add rows, all you just do is click on New and then change the drop-down menus to define whatever parameters or pieces of data that you want to export. And this is extremely flexible. You can export just about anything here. Now, let me go ahead and actually open up the Excel Export Manager while being in the output window itself. So I'm going to go to the Pump Summary tab, and I'm going to click on Pipes right here. And let me open this guy back up. All right. So let's break this down one by one. First row is I'm just showing the very generic piece of data, which is the model title. And I'm going to put that in sheet 1. That's going to be on the very first sheet in the Excel spreadsheet. The next thing that you would need to specify is a starting cell. Based upon the data that is going to be exported into Excel, we're going to calculate an ending cell for you. The next row is I'm going to do a column of data. So here you can do a single value, column, rows of data, tables of data, etc. Here I'm doing a column of data, which is the valve summary. So let me go to the valve summary tab here. Whoops, wrong button. All right. So in the valve summary, you can see there's several columns of data, and I'm only exporting 3 columns of data from the valve summary page. So the first thing is the junction name. So this gives the junction name valve A, B, C, D, E, and F. That's one of the things that I'm going to export into the spreadsheet. I'm going to have my starting cell be A5. The ending cell is calculated at A10. So here's cell A5, and it's going to export that data in that column. And then the next piece of data that I'm going to send is the volumetric flow rate. So again, it's also a column of data, which is volumetric flow from the valve summary tab. And I'm sending all of the column of data, and I'm going to start it in cell B3, which is right here, and it's going to be pasted all the way down. In this area, I'm turning on the header and the units. So this is where clicking on these buttons right here in this column is really helpful to show examples. So when you toggle on and off various units, you can see what it looks like. So here I just have the unit, but no header. If I turn the header back on, you can see how it changes. It's got flow area and the pipe numbers and the data. Now this is not valve stuff. This is just showing you an example of what that information of data is going to look like when you export it. And then the last part of the data for valves is going to be the K factor. So I'm exporting the K factor for all my valves, which are these values right here. So as you can see, there's a whole bunch of other data that's in the valve summary tab, and I'm not exporting all that data. I'm only doing various columns from the valve summary table itself. All right, now let's go to the pump summary tab again, and we'll move on to the next row. In this case here, let's skip the pipe. So for the pump summary, I'm showing everything that's in the pump summary as it's shown on the output window. So here I already configured this table for the pump summary tab. So when I do a table of data for the pump summary, everything that I've chosen to show is what's going to go in there. So it's going to show only these 4 parameters, nothing more. But let's go back to the pipes. The piping information here for row 5 is also using a column of data. So here I'm doing a column of data from the pipe tab right here. And as you can see, I'm exporting temperatures. Well, I'm not showing temperatures in the output window, but what this allows me to do is it allows me to still export any parameter that I want for whatever pipes are listed here. And that way you can still export data even if you're not showing it in the output window itself. So that's one of the things that gives you a lot of flexibility. And I'm going to send that to J2, and so that's where it's going to put the temperature data is right in here. Now, by the way, if you were to pick the wrong starting cells for any of these where you end up having data that overlaps with itself, you're going to see red in the spreadsheet example below. So if I tried to say A5 again, you're going to see red just like that. So this will help you figure out where you need to put your data so that nothing is overlapping. The last two rows of data here are my graphs. So if you create graph list items in the graph results window, like how I did, where you can simply regenerate them on the spot, then you can include those graphs to be exported as well. So I've got my profile and my pump and system curve, and I've got my 3-parameter header and my pump and system curve, and that data is going to be listed right down here. Now, when you're doing graph data, you're going to have to be a little bit more careful because it gets to be a lot more difficult to figure out exactly where the ending cell is. So this is where you might want to play around a little bit to just do some quick test exports to see, hey, where is that graph data going? What cell does it finish on? That way I can figure out, oh, if I'm doing a 3-parameter header and I'm starting on A20, that brings me out to here. Maybe my pump and system curve needs to start on L20. That way you don't have any overlap. So that might be one of the things that you might have to play with a little bit. Now, I am going to export all of this data into a spreadsheet just like this, and you have options to where you can either create a brand new workbook or you can send this data to a previously saved workbook, which I've already done. Now let's talk about batch runs. Again, I have 3 scenarios and I want to export that same data for all 3 scenarios. So doing a batch run is really easy. If we go to File and then Start Batch Run, this is where you pick which scenarios you want to run, and then I'm going to send the results to Excel using the Excel Export Manager. I want you all to pay very close attention to this because I've played around and I've tested it a lot. And so the key thing is, my suggestion, if you have multiple scenarios that you're wanting to sell, or if you're wanting to send to Excel spreadsheets, use the bottom option to send each individual scenario to a separate workbook. So as you can see, if I choose that option, it's going to create several Excel spreadsheets that are going to be named and numbered accordingly. And basically what this is going to do is it's going to do the full export where all of the results for each scenario will be in its own spreadsheet. So if I open up my folder where I'm sending all of that information, you can see that I already have those 3 spreadsheets that I've already created. So here's why I recommend that, is because these 3 spreadsheets that I've circled, those are my data dump spreadsheets. I'm not really doing any calculations in those. Those are just being my data dump spreadsheets, because ultimately the main spreadsheet that I care about is this one. It's called Excel Export Pre-Formatted. So what I've done is I've created this spreadsheet here where essentially I'm pulling data from the other 3 spreadsheets. So as you can see in this spreadsheet, I've already formatted it. I've created a graph. I've got a couple of different tabs. And so if we look at this carefully, you can see here that this is pulling from individual spreadsheets in this folder right here. So everything is named properly. Here's why this is really important, is because initially when you're setting this up, you may not have specified the actual changes in your scenarios yet. So they may all have the exact same values, because all you're trying to do is set up your data dump spreadsheets. That way you can format and prepare your data for your master spreadsheet. So the thing is, when you are exporting the data for your data dump, it's going to overwrite any data that's already in a spreadsheet. And so in order to do that cleanly, use the bottom option. Save the scenarios into separate workbooks. So now, if we take a look at the temperatures here, my temperatures are all 40 degrees Fahrenheit or so. That's because I'm using a supply temperature of 40 degrees Fahrenheit. Well, here's what I want to do. I want to change this to 80 degrees Fahrenheit. And what I want to have happen is I want to redo my batch run of all three scenarios. I want that to overwrite the data in the data dump spreadsheets right here, which will automatically update my master spreadsheet for me. So now when I go to redo my batch run, I should then see around 80-degree temperatures instead, and it will also automatically modify my pump and system curves. So let me close that, and now I'm going to go ahead and do a batch run. So go to File, Batch Run, Start. And so now, if I have 30 scenarios that I'm trying to run, go grab lunch, come back, and all of your scenarios will be ran, and all of the data will be exported into Excel. Incidentally, if you want to be able to plot pump and system curves of different scenarios together, where they're all on the same plot, and maybe you're modeling different liquid levels in tanks, maybe you're using different pump speeds, etc. This is how you would do it in Fathom 10, Arrow 7, and Impulse 7, or mainly Fathom, because Arrow and Impulse, you don't do pump and system curves. So here, I already did my batch run. Let's go ahead and open up the new pre-formatted spreadsheet. And I'm going to update the data. So just by inspection, it's hard to see if this information was actually updated. But if we take a look at the temperatures, bam, look at that. They're much higher than 40 degrees because I'm now getting my new temperatures based upon a 80-degree supply temperature. So this shows me that my spreadsheet updated properly for both my temperatures and my pump and system curves. So if you're using Fathom 10, this is how you would do it in an automated sense. Is you would do your Excel export manager with different scenarios, and then you can essentially pull data from individual spreadsheets and not plots them together. If you're using previous versions than Fathom 10, you could still do this, but essentially what you would need to do is just go to the graph results window for each individual scenario. You would load the scenario, and then you would regenerate your graph list item for that scenario. Click on this button to copy the XY data and then paste it into your spreadsheet. So you would have to do a lot of manual copying and pasting. Now, the moment that I've been waiting for is to be able to show you how incredible this is for our next version, AFT Fathom 11. You're going to love this. So I'm just going to go ahead and jump right into it, where now this whole thing, even with how the Excel Export Manager did automate this and make it more powerful, it's even better now. All right, so let me go ahead and open up Fathom 11. This is an internal beta release, only available to AFT, will soon be available to you all. And let me go ahead and open up my model. Excellent. All right, perfect. So here's what I have done is in my base scenario, I sized the pump with a fixed flow rate. And then in the pump curve scenario, I specified a pump curve from a real manufacturer. So I've got my pump curve, MPSH curve, and efficiency curve, and that way I can match my operating point. What I then did was I created all these families of scenarios. In each family of scenarios, what I did was I specified a certain liquid supply level for the supply reservoir, and then I did different pump speed children. So that's going to be the family where every supply reservoir in this family uses 25 feet for the liquid supply. In the next family, I've got my 100% speed pump, 95% speed, 90% speed, 80% speed, but for a 20-foot liquid supply level. And so I've got 15 feet, 10 feet, and 5 feet. And that's how I have set up my scenarios. Now, if you really want to be fancy, rather than doing all of your changes in the model, this is another area where you could do a really powerful import from Excel, where it's easier to copy and paste rows of data in that Excel workbook spreadsheet and then just import it in. And so that's another thing that you can make use of in that fashion. Now, I don't actually care about the pump curve scenario itself. All I'm going to do is I'm going to run this scenario, and the only reason why is because on the graph list manager, I'm going to create a pump and system curve for this system. I'm going to do user specified, and I'm going to increase my flow range to 800 gallons per minute. I'm going to show my efficiency curve, and I'm going to do 60 data points. And this is going to show the pump curve itself and the preferred operating region. So now when I generate this graph here, there's my pump and system curve. I need to go in here and click on this folder with the blue plus sign, add the graph to the list. I'm going to call it Ben's Pump and System Curve. So this particular graph list item is only serving as a template. So if the way that I've specified this graph list item here with all these parameters, if that applies to all of the other scenarios, meaning in any of these other scenarios, I've not deleted the pump, I've not changed the number, etc. If I've got a pump J203 in all of these other scenarios, that graph list item will apply to all the other scenarios. So after I created this graph list item, the next step is to go to File and then Start Batch Run. And here's where I specify which scenarios I want to run. So I'm going to do all of them except for the pump curve scenario and the base scenario. I don't care about those ones. So now when you do your batch run, this field is available where you can create a multi-scenario pump and system graph using the template. So here, you can make as many templates as you want. I've only made one. So I'm going to use this particular template, and what this will do is it's going to A, batch run all of these scenarios one after another, and it's going to create a pump and system curve for all of those individual scenarios, and then I'll be able to plot all of them together lickety split. I love this. This is just incredible. And so again, you've got 20 different scenarios that you're trying to run, and you go, you grab a cup of coffee, you come back, and you can actually now see how your pump operating envelopes are a lot more clarified when you're plotting everything together. The software developer that was working on this was able to actually finish up this feature yesterday. That way I could show it today. So I tested it out last night and it is outstanding. And so as you can see, it's going through, it's running each scenario. And then what it's doing is it's using the graph list item template that I made to create the graph list item for that scenario. And also what it's doing is it's creating a special graph list item folder for me, which is for doing multi-scenario pump and system curves. I know that it's probably overkill that I chose to do all 25 scenarios or however many there was, but it's just incredible and it's worth it. And so uh, you're going to love seeing this here. So it's just got a few more scenarios. Now, one of the things is that if you delete a certain pump J03 from any of those scenarios, then obviously that template item does not apply to that scenario anymore. So you have to make sure that everything lines up for all of your different scenarios for the template to work properly in that sense. If you're doing parallel pump and system curves, you can do the same thing. You would follow the same process that I did, where you set up your graph list item as a template, then do your batch run, and then you would be able to plot them all together. So now I've gone through and I've ran all the scenarios. So I have tons of output data available. And what I'm going to do is go to the graph results window. And let's break this down a little bit. So here's my previous template. This is the batch folder that it created for me automatically. And what it did was it took the template for each individual scenario and used that to generate a pump of the individual pump and system curve for each scenario. And it logged all of those into my batch folder. And it's listing the scenario name beside each pump and system curve. That way you know which pump and system curve goes with which scenario. The moment you've all been waiting for. I right click on the folder and I say load multi-scenario graph. Now, you can easily clean up this a lot here. There's a lot of data that I'm going to be specifying, so I'm just going to generate this, and the legend looks nuts. But you can easily go in and remove pieces of data because of the way that I've generated the pump and system curves. A lot of this is just duplicated and triplicated information. So you can clean a lot of these out here. But let me not show the legend, and bam, there it is. I've got my 4 pump curves together, 100% speed, 95, 90, and 85. I have the X's on each of the pump curves to denote the 70% and 120% range for my preferred operating region. I have each efficiency curve for the different speeds, 100% all the way to 85%. And lastly, I have the different system curves for each of the different liquid levels. So this is starting off where I had 25 feet all the way up to 5 feet for the supply liquid. And with this, you're not going to have to do the Excel exporting. So this makes it so much easier, and I'm super excited about it. And I hope that you are all just as excited as I am, because for those of you who love pump and system curves, this changes the game. There's no other tool out there that you could do as easy as this. So there you have it. Model importing, importing changes from an Excel spreadsheet, exporting whatever amounts of data you want from a model into an Excel spreadsheet. And this was a small taste of Fathom 11 that shows you how you can have a whole bunch of different scenarios and a very quick and easy way that you can plot all of your pump and system curves together for all the different scenarios that you're trying to run. Thank you all very much for your time today. I hope that you enjoyed the content, and we'll see you again in the next webinar. Take care, everyone, and have a wonderful rest of your week.